Okay, so in this problem, it's a word problem, and they're baking cakes. Oops. So I'm going to scroll up because we'll probably need a lot of room for this one. Don't let that scare you. Okay, a new bakery offers decorated sheet cakes for children's birthday parties and other special occasions. The bakery wants the volume, okay, so we know we're dealing with volume, of a small cake to be 351 cubic inches. Okay, so I'm going to need that information, and I'm going to need to know that I'm talking volume. We know it's a rectangular cake, don't we? Oh, no. The cake is in the shape of a rectangular solid. Okay, so maybe I'll draw a picture. Try to draw a picture of a cake that almost looks like a rectangular solid. Okay, use your imagination. Okay, we know we've done rectangular solid problems before. We know there's a width, we know there's a length, and we know there's a height for this cake. Okay, and the total volume is going to be that length times the width times the height. All right, so we're pulling out pieces of information that we know. Sometimes these problems are difficult and students struggle because they're trying to do everything at once. You want to take those pieces, those little pieces, and do what you can with them. And then when we run into trouble, we'll have to think of something else. But okay, they want the length of the cake to be 4 inches longer than the width. Okay, so now I'm getting somewhere. The length is going to be 4 inches more than the width. I'm going to use W for the width then, and W plus 4 for the length. Okay, and the height of the cake to be 1/3 of the width. So my height is going to be 1/3 W. Okay, that means I know my length and my height in terms of W. So now I can rewrite this function, or this formula for volume. I can rewrite it in terms of W. And I can say the length was W plus 4, the width, and then the height was 1/3 W. Okay, so I'm getting somewhere. Yeah, well, now what do I want to do? So I've got this multiplication going on, and there's different ways you could approach this. Also, we have not used the 351 yet, right? So we know that we want this, I'm going to write 1/3 W squared times W plus 4. So I'm simplifying this part to 1/3 W squared and then times W plus 4. And we want that volume to equal 351. Now, I'm not really happy about the fraction in there. This is an equation, so I can just multiply both sides by 3, and that gets rid of the fraction. It makes it kind of a large number on the right, but that's okay. I think it's 1053. Let me make sure. 315, carry the 1. That looks right. Okay, so now I'm getting somewhere. All right. If I set this to 0, okay, so if W squared, well, I'll just write it. W plus 4 minus 1053 is equaling 0. That means I'm finding the 0 of this function then, my volume. So now I have a volume function, okay? And I want to find the 0 of it. I'm going to distribute. So W cubed plus 4W squared minus 1053. And that's what I want to find the 0 of. So I can write it as a function, volume on W, and it would look like that. Okay, so now I want to use some of the ideas that we've been using in this section. So up to this point, we were just doing a word problem. We knew it was a rectangular solid, we knew length, width, and height, and we knew that we wanted it to be the volume to be 351 cubic, I think, inches. Okay, so we did some work with that, some algebra, and we come up with this function. Now we want to find a 0 for that function. So what does it mean? Well, I'd have to find then the factors of 1053. Now that's kind of a big number. So what I would do is I would start with what I know. I'd take my 1053, not too worried that it's negative, And I know 3 goes into that because we just did that. It was 3 times 351. Then I would think about, well, does 351 break down? Like what goes into 351? 9 goes into 351. So you might remember that rule: if you add up the digits and it's divisible by 9, the whole number is divisible by 9. So how many times does 9 go into 351? You could pull out a calculator here. It's going to go 39 times. Yeah, 39 times. And then 39 breaks into 3 times 13. Now what am I doing here? I'm breaking it down into prime factors. So whenever I have a big number like 1053 and I'm like, I don't know how to deal with that, I'm going to break it down into smaller numbers because then I can look at some things. All right, so now I have factors. I've got a bunch of 3's, 3, 3, 3, 3, and 13. So my choices for P are going to be 3, 9, 27, 81, right? Those are all different combinations of the 3's, right? I could have 1 3, I could have 2 3's, I could have 3 3's, and there's probably some other factors as well. And then there's also a 13. Okay, so there's other factors. Let's see. We're getting into some larger factors like 81. And let's see how I want to do that. Okay, see if I have them all. How many times did 9 go into 1053? Well, what's 39 times 3? So it's like 117? I think it's 117. And then how many times does 27 go into 1053? I'm going to cheat and use a calculator, even though my calculator is lousy. 1053 divided by 27, that gets me 39. Oh, I don't have the 39 written. And then I think we already have, I think we have them all, but we'll check divided by 81. 1053 divided by 81, 13. Okay. So we get this kind of matching up. Oh, I left off the 351. Okay, so those are all the factors of 1053. Now you wouldn't have to necessarily write those all out. You might say, well, I really don't think it's going to be 351. You know, yeah, it's probably not going to be that. But anyway, but there they are. And those are factors of 1053. Those are all the P's. Oh, I left off 1. 1's always a factor. Okay, Q, good news. Q is the factors of 1, so it's just 1. So it's just all those numbers that we've got. Now, how do we know which one it's going to be? We don't. So we're going to try. Now, I'm looking at that 1053 and I'm thinking that's a fairly big number. So let me try a fairly big number. Let me try 13. And what I mean by that is I'm going to try to divide synthetically and see if I get a 0. So I have 1 for a coefficient, 4, 0 because there's no x term, and then negative 1053. Now I don't know that 13 is going to work, but I thought it was my best guess. So 1 times 13, 17. What's 17 times 13? I don't know. 17 times 13, 221. Well, this looks like it's going to be a big number, so I don't think this is going to be it. It's 2873. Okay, so that's too big. Okay, so if you notice, look at, I'm getting all these positive numbers are just getting bigger. So I don't think 13 is, I don't think I want to go bigger than 13. So let me try 9. Smaller than 13. I don't think it's going to do any good to try 27 or 81 or 117, any of those numbers. I think I'm going to need something smaller than 13. Okay, so 1 times 9, 13. What's 13 times 9? 117. Okay, that seems somewhat reasonable. What's 117 times 9? 1053. It worked. So it was a little hard to think about that number 1053, and I'm just showing you how I would think about 1053. I would break it down into its primes, and maybe I wouldn't even list all the factors. Maybe I would try like 9 or 13 right off the bat, and then if that didn't work, then look for more factors. Okay, but we got it. Okay. Is it possible that there are more zeros? Well, there could be, I guess. You know, does 13 go into 117? I don't think so. So, oh, I didn't mean that. 117, what does 117 break down into? 9 goes into it. 9 times 13. Okay, so that's how that breaks down. But I don't think the factoring is going to work, okay? So I think we're going to want to stick with a cubic measurement here. I don't think you're going to be able to get a 13 from that, okay? So you could try factoring it, you could try the quadratic formula, but I don't think I need to. I'm going to say the 9 is good enough. Now what did we find? We found W, right? So we're going to say the width is 9 inches. And then remember the length was 4 more. So the length was going to be 13 inches. And then the height had to be 1/3 of 9. So the height was going to be 3 inches. I think it was in inches, not centimeters. Okay. So that looks like a good answer. You could multiply 3 times 9 times 13, make sure it's 351. That would be a good check. So what do we get? 27 times 13. Yep, 351. So that has a volume of 351. Looks good, and I would stop there.